Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing upper and lower bounds, and we shall be dealing with advanced problems. We shall begin with problems that require the parameter. An equilateral triangle has sides of length 6.2, correct to the nearest millimeter. Complete the statement about the parameter of the triangle. So here you are required to understand that the parameter of the triangle equals to the sum of its sides, side 1 plus side 2 plus side 3, for example. And since this is an equilateral triangle, so the sides are all equal to each other. So this is actually just s plus s plus s, or rather just 3 times s. 3 is a constant. We don't work on it. We just try to figure out what to do with the s. So we want the lower and upper bounds of the parameter. We want both because we have two blank spaces to fill. So we need to figure out the level of accuracy. The level here is millimeter. 1 millimeter equals 0.1 centimeters. We divide by 10, and we multiply this number by half to get the bounds. So we get 0.05. So this is the number that we're going to add or subtract for s. So s will be 6.2 plus 0.05, or 6.2 minus 0.05. Let me just fix this 5 so that it's different from s. So our numbers will lie between 6.25 and 6.15. The parameter is 3 times s. So the parameter will either be 3 times 6.25 or 3 times 6.15. And we can use the calculator to figure this out. So we have 18.75. And we have 3 times 6.15, which is 18.45. And we write these numbers down as a final answer. 18.45 and 18.75. And these are the correct final answer. The sides of an equilateral triangle are 9.4, correct to the nearest millimeter. Work out the upper bound of the perimeter of this triangle. So again, this is perimeter and equilateral triangle. So we already know that we're multiplying 3 times the side. Here we just want the upper bound, so we're just adding, not subtracting. And the unit again, or the level of accuracy, is millimeter, which is 0.1 centimeters. We multiply that by half. So we get 0.05. So the side will be 9.4 plus 0.05. And that gives us 9.45. And the parameter would be 3 times the side. So 3 times 9.45. And we calculate this. So 3 times 9.45 gives us 28.35 as a final answer. And this is the correct answer here. So this is another similar question again. We have an equilateral triangle with side length 15 centimeters, but here the level of accuracy is 1 centimeter. So we don't need to do any conversion of units, just need to multiply it by half, and we get 0.5. So this time we're adding 0.5, not 0.05. But again, the parameter is 3 times the side. So we need to first get the side, which will be 15 plus 0.5. And this gives us 15.5. Now the parameter would be 3 times 15.5. And this gives us 46.5 as a final answer. This is correct as well. A rectangle has length 5.8 and width 2.4, both correct to 1 decimal place. Calculate the lower bound and the upper bound of the parameter of this rectangle. So we need to figure out what the parameter of a rectangle is. The parameter of a rectangle is basically length plus width plus length plus width. We're moving around the shape. So we start at a point. We move, we have here L, and then W, and then L again, and then W again. So we can write an equation for the parameter. P equals L plus W multiplied by 2, or 2L plus 2W. You can write whichever equation you want. Now we want the upper and lower bounds, and here we have addition and multiplication. So for the upper bound, we just need to get the upper bound of L and the lower bound and the upper bound of W, and then multiply by 2. For the lower bound, we would still need to get the lower bound of L plus the lower bound of W, and then multiply by 2. So the length here is 5.8, correct to 1 decimal place. So 1 decimal place is 0.1. We multiply that by half. We get 0.05. So we're adding and subtracting here 0.05. So the upper bound for L will be 5.8 plus 0.05, which gives us 5.85. And the lower bound, let me just redirect the arrow. The lower bound here will be 5.8 minus 0.05, and this gives us 5.75. So these are the bounds for L. Let's write them down. Upper bound is 5.85, and lower bound is 5.75. We will repeat the same process for W. So W equals 2.4. Let me just get some space here. W equals 2.4. Therefore, W upper will be 2.4 plus 0.05, which is 2.45. And W lower will be 2.4 minus 0.05. And this is 2.35. And these are the values for W. Let's write them down. 2.45 and 2.35. Our final step will just be to substitute these values into our equations. So for upper bound of parameter, we're just going to use the upper bound of the length, which is 5.85, and the upper bound of the width, which is 2.45. So 5.85 plus 2.45. This gives us 8.3, and then we multiply the answer by 2, we get 16.6. So the upper bound is going to be 16.6. And for the lower bound, we will do the same thing again. We will just plug the values into the brackets. So for the L lower, this is 5.75. For W lower, this is 2.35. So 5.75 plus 2.35 gives us 8.1. We multiply the answer by 2, we get 16.2. So for the lower bound, we have 16.2. So let's check the final answer. These are the correct values, 16.2 and 16.6. The length of the side of a square is 12, correct to the nearest centimeter. Calculate the upper bound for the perimeter of the square. So a square is like a rectangle, but the length and the width are the same value. We have S, 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 and S. So the parameter here is just S plus S plus S plus S. So P equals 4S. The 4 is a constant. We don't do anything to it. So we just need to manipulate the S. Here we want the upper bound. So we just need to add, not subtract. And the level of accuracy is 1 centimeter. So we multiply that by half. We get half a centimeter. So we're just going to add half to this value. So we have 4 times 12.5. How did I get 12.5? I just added 12 to 0.5. 12 plus 0.5 equals 12.5, of course. So the parameter is 4 times 12.5. And this is equal to 50. So the final answer is 50. The sides of a triangle are 5.2, 6.3, and 9.4, each correct to the nearest millimeter. Calculate the lower bound for the perimeter of this triangle. So we said before that if we have a triangle and we want to move around it, starting at this point, we would move S1, and then S2, and then S3. So the parameter is just basically the sum of the three sides, P equals S1 plus S2 plus S3. We are adding them together and we want the lower bound. So we're just going to get the lower bound of each side. So L, L, L. Now, the level of accuracy is 1 millimeter, which is 0.1 centimeters. And we need to multiply that by half. And we get 0.05. So this is the lower bound. Excuse me, this is the number that we're adding and subtracting. And we are going to subtract because we are seeking the lower bound. So basically, we're going to subtract 0.05 from each side. So all of these will just be minus 0.05. We get 5.15, 6.25, and 9.35. Now that we have our numbers, we can just plug them into the equation. So 5.15 plus 6.25 plus 9.35. We have 20.75 as a final answer. An equilateral triangle has side length 12, correct to the nearest centimeter. Find the lower bound and upper bound of the perimeter of the triangle. So this is an equilateral triangle, so they all have the same length. So the perimeter will basically be 3 times 12. Of course, it's not actually 12, it's just, let's call it S for now. The S is represented here by the 12. However, we need to figure out the lower and upper bounds. So this is 1 centimeter. We need to multiply that by half. We get 0.5. This is what we're adding and subtracting. So we have 12 plus 0.5 and 12 minus 0.5. So we have 12.5 and 11.5. So for the parameter, you either have 3 times 12.5 or 3 times 11.5. This is 37.5 and this is 34.5. So therefore, the lower bound is 34.5 and the upper bound is 37.5. And these are the correct answers here. Next, we move on to area and volume. A rectangle has length 62 millimeters and width 47 millimeters, both correct to the nearest millimeter. The area of this rectangle is A. Complete the statement about the value of A. So again, we need to get the lower and upper bounds for the area. We want the area of a rectangle, so you should know that for a rectangle, you have width and length. The area is L times W. So we're multiplying here L and W. The L is 62 and the width is 47, both correct to the nearest millimeter. So we have the same unit here and here, but we need to multiply, of course, by half. So 1 millimeter times half gives us half. So let's get the upper and lower bounds for each. We have 62 plus half. This is the L upper, which is 62.5. And then the lower bound for the length will be 62 minus 0.5, which is 61.5. The upper bound for the width will be 47 plus 0.5, which is 47.5. And the lower bound for the width will be 47 minus 0.5, and this is 46.5. We want the upper and lower bounds for the area. So of course, area upper equals L upper times W upper. And area lower will be L lower times W lower. We now just need to plug the values that we already got. So L upper is 62.5 multiplied by W upper, which is 47.5. And area lower is L lower, which is 61.5 multiplied by W lower, which is 46.5. We can now use the calculator to evaluate these two expressions. So this expression here is 62.5 multiplied by 47.5, which is 2,968.75. For the lower bound of the area, we have 61.5 multiplied by 46.5. And we get 2,859.75. So the lower bound is 2,859.75. And the upper bound is 2,968.75. And these are the correct answers. The sides of a square are 8 centimeters, correct to the nearest centimeter. Calculate the upper bound for the area of the square. So a square is similar to a rectangle, but instead of L times W, we just have S times S. So for the side here, it's 8 centimeter, correct to the nearest centimeter. So 1 centimeter. We multiply this by half, of course. We get half as a final answer. We are adding or subtracting, but here we want the upper bound, so we're just adding. So we have 8, S equals 8 plus 0.5, which is equal to 8.5. So A equals S times S, which is 8.5 times 8.5. And the answer can be obtained using the calculator. 8.5 times 8.5 gives us 72.25, and this is our final answer. The size of a square are 15.1 centimeters, correct to 1 decimal place. Find the upper bound of the area of the square. So like we just said before, the area of a square is side times side. We have a level of accuracy of 0.1, 1 decimal place. We multiply that by half, we get 0.05. This is what we're adding or subtracting. Here we want upper bound, so we're just adding. So the S is going to be 15.1 plus 0.05. And this is 15.15. So the area equals 15.15 times 15.15. Use the calculator to evaluate this. And the answer is 229.5225. And this is the correct answer here. The area of a square is 42.5, correct to the nearest 0.5. Calculate the lower bound of the length of the side of the square. So let's first get the lower bound for the area. We said before that the area of a square is side times side. And the area itself is 42.5, correct to the nearest 0.5. Let's multiply that by half. We get half times half, which is 0.25. So we're adding or subtracting 0.25. Here it's lower bound, so we are subtracting. So our lower bound for the area will be 42.5 minus 0.25. And this gives us 42.25. This is the area of the square. Now we want a side length that we multiply by itself to get 42.25. So this is algebra now. So S squared equals 42.25. So S will be the square root of 42.25. So root of 42.25 gives us 6.5, and this will be the final answer. 6.5 here is correct. The base of a triangle is 9, correct to the nearest centimeter. The area of this triangle is 40, correct to the nearest 5 centimeters squared. Calculate the upper bound for the perpendicular height of this triangle. So the area of a triangle equals half times base, which is this side, times height, which is the perpendicular height that they are talking about. So this is our formula. We want to get the upper bound for h, so we need to rearrange the equation to get h as a subject. So we have a equals b times h over 2. This is the same as this. These are exactly the same. We can multiply both sides by 2. These will cancel out. Now we have 2a equals b times h. We want to get h, so we can divide by b on both sides, and these will cancel out. So our formula here is going to be h equals 2a over b. As we mentioned in the previous video, if you're dividing or subtracting, the first term follows your h, and the second term is the reverse argument. So in other words, we want to get the upper bound, so the area needs to be upper and the b needs to be lower. Because we want to maximize h, so we want to maximize the numerator and minimize the denominator. Same thing as with difference, just reminding you, if we have x equals b minus a, to maximize x, we would need to maximize b and minimize a. So you always maximize the first and minimize the second, or you do the opposite. So if you're trying to minimize x, you would minimize b, and then maximize a. So the first term always follows the x, or the target variable in a sense, and the second term always opposes it in terms of the relationship. Same thing as with fractions. So if we have x equals b over a, we want to minimize x. So we would minimize the first term, the upper term, and maximize the lower term. So here we want to maximize the a and minimize the b. Now let's look at the levels of accuracy. So the b is 9, correct to the nearest 1 centimeter. So 1 times half equals half. For b, we are trying to minimize, so b equals 9 minus half. This is 8.5. For the area, it's 40, correct to the nearest 5. So we multiply this by half, we get 2.5. And the area will be 40 plus 2.5 because we're maximizing the area. So 42.5. Now that we have a and b, you can plug into the equation. H equals 2 times 42.5 divided by 8.5. And the final answer is 10. 10 is the correct answer here. The volume of a cuboid is 878 centimeters cubed, correct to the nearest cubic centimeter. The length of the base of the cuboid is 7, correct to the nearest centimeter. The width of the base is 6, correct to the nearest centimeter. Calculate the lower bound for the height of the cuboid. So you should know that volume of a cuboid is like a box, something that looks like this. You have length times width times height equals volume. So volume equals L times W times H. We want to find the lower bound of H, so let's just isolate. We will divide by L and W. So L cancels L, W cancels W, so H equals V over LW. H equals V over LW. We want to minimize the height. We want the lower bound for the height. So like we said, the first one follows the pattern, and the ones in the denominator follow the reverse pattern. So we want to maximize those. So we want to minimize the volume and maximize L and W. So the volume equals 878, correct to the nearest cubic centimeter. We're minimizing, so we're subtracting. And we need to figure out the level of accuracy here. So this is 1 centimeters cubed. We multiply this by half, we get half. So we're just subtracting half here, and we get 877.5. For the L is 7 centimeters, correct to the nearest centimeter. So again, this is just 1 times half equals half. But here for the L, we're maximizing, so we want to add half. This is 7.5. For the W, it's 6 to the nearest centimeter again. So again, here, this is 1, multiply by half, you get half. And we are adding to maximize. So the W is 6 plus half, which is 6.5. So we just plug these values into the formula. We have H equals 877.5 divided by 7.5 times 6.5. So you use the calculator to figure this out. This is equal to 18 as a final answer. Finally, we are going to deal with motion problems. And you should know the equation of motion, which is distance equals speed times time, or distance equals speed times time, or x equals v times t, whichever one you like. They mean the same thing. This is distance, this is speed, and this is time. Both of them would work. Use whichever one you want. Anna walks 31 kilometers at a speed of 5 kilometers per hour. Work out the upper bound of the time taken. So we want the time. I'm just going to work with I'm going to work with the first one, might be more familiar. So we want the time here. So time equals distance over speed. And we want to find the upper bound of the time. So the upper bound means I want the upper bound of the distance and the lower bound of the speed. Now the distance is 31 kilometers. And the speed is 5 kilometers per hour. And both of them are correct to the nearest whole number. So this is 1 times half equals half. For the distance, we want to maximize. We want the upper bound. So this is plus half. For the speed, we want the lower bound. So this is minus half. So here we get 31.5. Here we get 4.5. And then we plug them into the equation. T equals d over s, which is 31.5 over 4.5. So 31.5 divided 4.5 gives us 7. So 7 is the final answer. For the final question on this video, we are told on a different journey, the train took 73 minutes, correct to the nearest minute, to travel 215 kilometers, correct to the nearest 5 kilometers. Calculate the upper bound of the average speed of the train. So let's use the same equation again. Distance equals speed times time. We want the speed, so we rearrange the equation. This is the same as dividing both sides by t, for example. So S equals d over t. Now we want the upper bound of S, so we want the upper bound of d and the lower bound of t. Now let's figure them out. So for the distance, we are given that it's 215 kilometers, correct to the nearest 5 kilometers. So we multiply this by half, we get 2.5. And for d, we want the upper bound, so this is going to be plus 2.5. For the time, well, let's just evaluate this first. So this is going to be 217.5. For the time, we have lower bound. So the time itself is 73 minutes, and this is correct to the nearest minute. So 1 minute times half gives us half. So we're adding or subtracting half. Here we are subtracting to get the lower bound. So this is 72.5. Now we plug into the equation. So the S equals distance, which is 217.5 divided by 72.5. We use the calculator to evaluate. And the answer is 3. Final. So now the final answer is 3, but this will be in terms of kilometers per minute. We want the speed in kilometers per hour. So to get 1 hour, it's 60 times this number, because in 1 minute, they cover 3 kilometers. So in 1 hour, they would cover 60 times that amount. So the final answer would be 180 kilometers per hour. If you want a more mathematical way of doing it, 3 kilometers per minute equals what kilometers per hour? So kilometer to kilometer, there is no change. You can write 3. From minute to hour, you are dividing by 60. So 1 minute becomes 1 divided by 60. But this is a bit complicated unnecessarily. But anyway, you can think of it this way. So it becomes 3 divided 1 over 60, which is 3 times 60, which is 180. So the final answer is 180 kilometers per hour. And this is the correct answer here. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.